Hi everyone, welcome back. We are on lesson 5 in our linear relations part 2 unit, and the topic is called equation of a line review. So I'm just going to go through some of the things that we talked about in previous lessons. So to start off, the first question is asking you to graph the following relation using x and y intercepts. So there's your equation here, and we're going to find the x-intercepts, so the x-intercept and the y-intercept, and that will give us 2 points that we can join and draw a straight line through those 2 points. So to find the x-intercept, you want to let x equal to 0, or let y equal to 0. I'm just going to correct this. There we go. Let y equal to 0. So you're taking your equation, and wherever there's a y, you're going to replace it with 0. Okay, and then you can solve for x. So this middle term is going to disappear, and you will have 3x equals 12. And then you can divide both sides by 3 to give you x equals 4. Okay, so that gives us the point 4, 0, right? That's the line. That's the point on the x-axis at 4. 1, 2, 3, 4. So I'm going to put my x-intercept right there, and we need a second point somewhere along the y-axis. So we'll find the y-intercept in the same manner. So now replace the x with 0. So in this equation, wherever there's an x, put a 0. Okay, that term will be gone because 3 times 0 is 0. So we have 2y equals 12. Divide both sides by 2, and y equals 6. Now we have a second point, which is at 0, 6. 1, 2, 3, 4, 5, 6. There we go. And you can take your ruler and draw a nice straight line, and you want to make sure that your equation is labeled. Okay, especially if you're going to have more than one line on your graph. Okay, you want to make sure that they're labeled. I'm going to add a second line to this, all right, for the second question. Determine an equation given that the x-intercept is 4 and the y-intercept is 3. Okay, so we are given 2 points here. If the x-intercept is 4, okay, that means we have a point on the x-axis at 4. That's just going to go over my purple dot there, right? And the y-intercept is 3. That is our second point. 1, 2, 3. Okay, so I know what my points are. Now, to write them as coordinates, right, it would be 4, 0, and 0, 3. So now I have those 2 points. To write the equation, what you need to do is find the slope next. Okay, so how do you get from the left dot to the right dot? You're going to go down 3 spots and over to the right 4 spots. Okay, so that gives us a slope of -3 over 4. Y-intercept is given in the equation, right? The y-intercept is our dot that runs through, or on the y-axis, and that's going to be at 0, 3. Okay, so now you can write your equation. So replace your m with our slope, -3 over 4, and then replace your b with number 3 because that was our y-intercept. Okay, so I'm just going to add a line through my 2 dots. And I've got my equation here ready, labeled. All right, so those were part of the warm-up. And a little bit of what you should recall, what we've covered before, is there are 2 forms. We have the y equals mx plus b, which is called the slope and y-intercept form. And then we have the second form here, ax plus by plus c equals 0, and that's called the standard form. M in the slope and y-intercept form stands for slope, and the b stands for the y-intercept. Determine the equation of a line given these 2 points. Okay, so equation of a line, you will always start by finding y equals mx plus b. All right, even if the question says determine the equation of a line in standard form, you can't write that form unless you have the slope and y-intercept form first. So always start with that. But in this question here, it doesn't say to write it in standard form. It just says write the equation. So you can just stop after you have it in y equals mx plus b. All right, so to find the slope between these 2 points, you could graph them on a piece of graph paper and just count up what the rise over run is, or you might remember this equation here, y2 minus y1 over x2 minus x1. So if you are using that, I'll just help you out by labeling our points. So I'm going to call this my first point and this my second point. Okay, it doesn't matter which is first, second, just this one's written first. I'm calling it my first point. And every point needs an x and a y. So x and a y. And because I'm calling this the first point, I'm going to give these little ones, little subscripts of ones, and I'm going to give these little twos. Okay, so in the equation, when it says y2 minus y1, it would be the y2, which is a 2, minus y1, which is a 4. So at the top, you want to have 2 subtract 4. And at the bottom, you want to have 9 subtract 3, right? x2 minus x1. And I worked out the top and the bottom. 2 minus 4 is negative 2, 9 minus 3 is 6, and then you can reduce that to negative 1 over 3. So there we go. We have our slope. Now to find the rest of the equation, we're going to write down the y equals mx plus b form. We can replace our m with negative 1 over 3 because we just found that. And we can replace the x and a y with one of these 2 points. And then that will allow us to solve for the y-intercept, which is our b. I'm going to go ahead and just use the first point. You can use the second point and you will get the same answer. So my x would be 3 and my y would be 4. Okay, and then I also replace my m with my negative 1 over 3 from the earlier section. Okay, now you can multiply negative 1 over 3 times 3, which would give us negative 1. Okay, and then bring the negative 1 to the other side, which means we're going to add now because it's negative here. So 4 plus 1 is 5. And b is 5. So now you can write the equation because now we know what b is and we know what m is. Okay, so just replace them in the equation. And that's it for that question. Example 2 is a word problem. And this is the last question I'm going to do, but it has several parts to it. So we have a candy store is making up a mixture of chocolate-coated almonds and chocolate-coated raisins. That sounds delicious. The almonds are $30 per kilogram, and the raisins are $8 a kilogram. So they're much more expensive. The final value of the mixture is $150. So you're going to try to figure out, how much, what are the different possibilities, right? How many almonds can you have? Compared to how many raisins can you have in order to be able to spend $150. There's lots of different scenarios. Right, now algebra expression that describes this situation. So I'm going to let A represent the amount of almonds and let R represent the amount of raisins in kilograms. Okay, so my equation is going to be 30A, because $30 per kilogram of almonds, plus 8 are $8 per a kilogram of raisins. And the total amount we have to spend is $150. And then we're going to write down some of the different scenarios that can happen. So we're going to create a table of values showing 6 possible combinations of the almond and raisin mixture that can be made for $150. So let's start off with 0 almonds, right? So if we just buy raisins, how many can we purchase, right? How many kilograms can we purchase? Okay, so I took my equation that I have here and I replaced replace the A with 0. So all we're left with is 8R equals 150, and then divide both sides by 8 to give you the amount for R. All right, so if we don't spend any money on almonds, if we just purchase raisins, then we can buy 18.75 kilograms of raisins. Let's look at the other extreme. All right, let's say that we're not spending any money on raisins. We just want those chocolate-covered almonds. Delicious. All right, so we're going to take the same equation, replace your R with 0. So you're left with 30A equals 150. Divide both sides by 30, and you are left with A equals 5. Okay, so if you just want to buy almonds, you're going to spend $150. You can buy 5 kilograms of chocolate-covered almonds. All right, and then now you can get the data in between, right? So this is linear, and since we have 0 up here and 5 up here, these have to be increasing by the same amount. And if you're going from 0 to 5, you can guess that this is going to be 1, 2, 3, 4, and then the last one 5. Okay, and now one by one, you can sub these into the equation to find out what your R is. So if you purchase 1 kilogram of almonds, you can purchase 15 kilograms of raisins, and so on. So I did it for the other values. Okay, so those are all the different possibilities. Question C, create a graph of this relationship. So this is our data from the previous page. And I just plotted these points. I've got my raisins on the y-axis and my almonds on the x-axis. It doesn't matter, right? I mean, the way I have it written here, I'm saying, you know, the amount of raisins you purchase depends on the amount of almonds. So this is the raisins is independent, and then almonds is dependent. Or the other way around, sorry. Raisins is dependent and almonds is independent. But I could have swapped those, right? It's just the way they were in the table, written down initially. Right, it's usually the x column goes first, or the x-axis goes first, the y-axis goes second. So that's how I decided to create my graph. But they could be reversed. All right, question D, find the greatest mass of almonds that can be used in the mixture. So what is the most amount of almonds that we can use? So just look at your values here, and we've got 5, right? That would happen when there are 0 raisins. And then also greatest mass of raisins that can be used, 18.75, and that will happen when we don't purchase any almonds. Find the mass of raisins if the mass of almonds is 2.5 kilograms. So a couple different ways of doing this. You could look at the chart or your graph, and I'm just going to double check what was our number here. 2.5 kilograms of almonds. 2.5 kilograms of almonds. So that would be right in between here. So the number between 7.5 and 11.25. You could look at your graph and go along to almonds at 2.5, which would be here, and go right up to your graph. It looks like it's going to be a little bit over 9, right? So you could estimate it using your graph and your chart. But let's find the exact amount algebraically. Okay, so using your expression that we came up with, almonds is 2.5, so I'm going to replace my A with 2.5. Right, multiply those together, give you 75. Bring the 75 to the other side, so 150 minus 75 is 75, and then divide both sides by 8. And we get 9.375. So we said a little bit over 9, but this gives us the exact amount. Find your mass of almonds if the mass of raisins is 10 kilograms. So same thing I did here. I used the same expression and then just replaced my raisins with 10, and I got 2.3. And question H. By looking at the graph table, you can see that almond weights can only be between 0 and 5. So those would be the restrictions, right? Almonds, we can have more than 5, and we can have less than 0. So between 0 and 5, and then raisins are between 0 and 18.775, right? If you wanted to write, we could also write it as, oops, there we go. Okay, so almonds less than or equal to, what's the biggest almond value? 5. And bigger than or equal to 0. Okay, so those are the restrictions on A. And the restrictions on raisins. Raisins are less than or equal to 18.75. And bigger than or equal to 0. Okay, so there you go. So those are some review questions if you had some trouble with some of the lessons we've done the last couple weeks. And for homework, you're going to try lesson 5, page 8. And it's these questions here. So they're on page 8. And I'll just give you some tips. For the first question, determine the equation standard form using the x and y intercepts. So you want to start out by writing it in y equals mx plus b form. All right, you're always going to do that. You know, look find the slope between your two dots. It looks like we're going up 1, 2, 3 squares, and we're going across also 3. So it looks like slope is going to be 1, right? And then your y-intercept, where does it cross the y-axis? It looks like it crosses at -2. So your b is going to be -2. Okay, so always start out by writing your slope and y-intercept. Put this into y equals mx plus b form, and then rearrange the terms to put it into standard form. Question 2. Determine the equation of a line in standard form. And then, so you're given different scenarios, right? So I said here, write in y equals mx plus b form first, and then rearrange it. Okay, so this one here, you're getting an x-intercept of 3. So that's going to be an actual point, right? X-intercept of 3, that's an actual point of 3, 0. So that's your x and y. And then you're also given a y-intercept of 6. Right, so you can write it in this form, because what you can do is, well, the y-intercept you're given is 6, that's your b. To find your slope, write the second point. Y-intercept of 6 is going to give you 0 and 6. So now you've got 2 points, and you can use those to find your m, to find your slope, like I did in the example earlier. And so this is kind of the method that you're going to use, right? And then you get into some tougher questions a little bit, right? This one is a vertical line that passes through 5 and 12, right? So it's a vertical line that's passing this point. I would plot this point on a grid, and then draw a vertical line, and then ask yourself, what does an equation of a vertical line look like? We did that in either last week's or the week before homework. Okay, the last couple of lessons included vertical lines. What do those equations look like? Number 4. Okay, this number 4, you can use a similar method as I showed you here. You've got 2 points, right? Use that to find slope, and then find your y-intercept. I think it was up here. Yeah, this question here, right? You're given 2 points, find slope, and then find the y-intercept, similar to that. So, work your way through these questions. Let me know if you need a little bit of help, and I will help you out. All right, good luck, guys.